So far there's almost 6 students already connected. If you're here late, then the code's right here on the top right corner for you guys to join, and you'll still be going along with us with this presentation. And so to present myself, I'm Marisa Llamas, and today I'm going to be teaching you guys how to write equations for parallel lines. But before, out of these 4, which one is your favorite song? We have 4 contenders. Number 1, We Are Never Getting Back Together by Taylor Swift. Option number 2, Driver's License by Olivia Rodrigo. 3, if you're more into those classic guitar riffs, Queen's Bohemian Rhapsody. Or if you're more laid back with country, All My Exes Live in Texas by George Strait. The responders already, and so feel free to just pick out of these 4 which one's your favorite song. And right now I'll show you guys your responses here. Oh, and there's a tie. There's a tie between Driver's License and Bohemian Rhapsody. I don't think you guys are much country lovers or fans of Taylor Swift. So the reason I ask you guys what's your favorite song is because one of these songs actually ties in with a lot with parallel lines. And this is Taylor Swift. Parallel lines are 2 lines on the same plane that are never going to meet. The same plane meaning on the same surface. And so some examples of parallel lines are these 2 sets of lines right here. This red lines, they're going to keep on going. If you stretch them out into forever, into infinity, they're never going to cross each other's paths. The same thing with these 2 purple lines right here. The more you stretch them out, it doesn't matter if you stretch them out 100 miles, they're never going to cross each other. Some non-examples of parallel lines, however, are these 2 sets of blue lines right here. The lighter blue, they're crossing each other in the middle right here, so that doesn't make them a parallel line. And even though this darker blue, these 2 lines, even though they're not crossing each other right here, the more you stretch them out, eventually they're going to end up crossing right here. I like to call this the Taylor Swift code of parallel lines, because like parallel lines and Taylor Swift, they're never ever going to get together. Feel free to unmute yourselves if you understand the topic, or if not, to just add on to Pear Deck right here of your responses. Option 1, I don't understand at all. Option 2, can you explain a little bit more? Or option 3, I understand and I'm good to go. Okay, so most of you guys are understanding, and so that's great. I'm gonna move on with the lesson. And so we've all seen this famous formula, y is equal to mx plus b. This is called slope-intercept form. The m is your slope, and the b is equal to your y-intercept, hence the name slope-intercept form. And so this is the basic foundation to what you guys are going to use whenever you guys are graphing or whenever you guys are writing equations for lines. And so with this being said, what makes graphing parallel lines so special? With parallel lines is that their slopes are always going to be the same. It doesn't matter if one slope is 100, the other slope is also going to be 100. It doesn't matter if one slope is -5, the other slope will also be -5 of the parallel lines, because they're always going to be the same. You can remember this with the direction rule. Because parallel lines go in the same unchanging direction, they're going to have the same slope. If you look at line A and line B over here, they're going to keep on going this way forever and ever and ever. It's an unchanging direction. Line A is not suddenly going to go left or suddenly go right. They're going to keep on going straight, almost into infinity. And because of this, because they have the same direction, both lines are going to have the same slope. Does everybody understand? Feel free to unmute yourselves or to use the chat. So I'm getting a lot of yeses. I'm going to ask you guys a question. So with this being said, with the direction rule in hand, same direction equals the same slope. If the equation of line A is equal to 2x plus 3, what is the slope of line B? Assume these 2 lines are parallel. Does anybody want to take a guess or a crack at this problem?
2.
2? Why?
Well, because it says 2x, and that's how you find the slope.
So, because it says right, guys, the thing with this equation is that we're always going to use y is equal to mx plus b. the m is equal to the slope and the b is equal to your y-intercept. Here, they're only really asking you for the slope of line B. We know, because of the direction rule, that parallel lines go in the same direction. They're going to have the same slope. The slope of line A is going to be the same as line B. And so, Itzel was right. The slope of line B is also going to be 2. And the next question, what is the slope of line B if the slope for line A is -5 and both lines are parallel to each other? I have a lot of you guys responding already. Does anybody want to unmute yourselves and to just explain the process and to explain your answer?
The slope is -5 because, well, they're saying the slope is -5 for line A, and line A and B are both parallel.
Good job. And so this goes hand in hand with the direction rule. Because parallel lines have the same direction, they're going to have the same slope. And so I can see that all of you guys answered the correct answer. Because the slope for line A is -5, the slope for line B will also be -5. And so now this one, now it says, instead of asking you guys the slope, now it's asking you guys to actually write down the equation of line B if the equation of line A is y is equal to x. If this is our regular format for graphing equations, y is equal to mx plus b, what's going to be the slope for this line right here? No number here. There's kind of going to be, it's going to be a regular imaginary. There's an imaginary 1 right here in front of the x. And there's no plus b because it doesn't have a y-intercept. It's going right across the origin. The slope of line A is 1. If we already know that the slope of line A is 1 and these two lines are parallel, which one of these can we cancel out? Can we automatically just cross off?
B and D.
Yeah, because B and D have a slope of 5 and 3. So those you can automatically cancel them out and just take them off your responses. But the only problem is we need to figure out what's line B's y-intercept. And it might look a little difficult, but all you have to do is really just count where it's in the name, y-intercept. You need to find out where line B is crossing the y.
2.
Yeah. Wait, +2 or -2?
+2.
B is crossing it at +2. And because of this, the equation of line B is going to be, x is equal to +2. So to review, this is the direction rule. Like the direction rule just says, if they have the same direction, no matter if it's going right or left or up and down, they're going to have the same slope. Just that's one part of the summary that we've been going over in this lesson. And the second part is the Taylor-Swift code of parallel lines. Does anybody want to reiterate what Taylor Swift has taught us about parallel lines?
Never getting together.
Yeah, they're never gonna get together. They're never gonna intersect. They're gonna go their own separate ways, and they're never ever gonna get together. Hope you guys enjoyed this lesson, and let me know in the chat if you guys had any trouble with it. You loved it? Okay. Thank you. Thank you. And I hope you guys remember that whenever you guys are listening to Taylor Swift, that to think of parallel lines. And thank you guys for your time. I really do appreciate you guys sitting here letting me teach you about parallel lines. And so thank you.